Hello everyone, this is Harshita studying in HMEC in Sri Venkateswara College of Engineering, Bangalore. Today I am going to explain you about the topic CNN-based object recognition and tracking system to assist the visually impaired people. The contents are introduction, literature survey, methodology, results, applications, conclusion, and references. The flow of the paper, introduction, literature review, the proposed framework, experimental results, and analysis. Moving on to next slide, we have introduction. Object recognition and tracking system based on convolutional neural networks have shown remarkable performance in detecting and recognizing objects in real-world environments. Visually impaired is a condition that affects a person's ability to see. It can range from partial sight to complete blindness. Independence plays a significant role for achieving goals and objectives in life. The independence and security of their daily activities and outdoor travel are necessary for them. A possible use for CNN-based object recognition and tracking system is to help the blind go about their daily lives. These systems can be used to find and identify environmental obstacles like traffic lights, pedestrian crossings, and other objects. These systems can aid visually impaired people in more safely and independently navigating their surroundings by giving them real time feedback. This figure gives us the assistive device for VIP. This contains detection, hybrid, and navigation. Next, we have objectives. Some of the objectives of CNN-based object recognition and tracking systems are: first, we have to understand and provide visually impaired with the information they need to safely cross the road. Second, to create the system which will identify object in the scene in order to provide information to the user in real time. To track objects in real time as they move in the user field of view, to recognize and classify objects in the environment accurately. This can include detecting and identifying everyday objects such as chairs, tables, doors, and stairs. To have a user friendly interface that can be easily navigated by a visually impaired people. Some of the papers which I have referred for my literature survey are: first, we have Smart Assistive System for Blind People using Raspberry Pi by Maria Anu. The pros and cons are: it is portable, making it easy for the user to carry with them. It can also be designed to perform multiple functions such as obstacle detection and text to speech conversion. The system may be not compatible with all hardware devices. It has limited connectivity options, which can restrict the ability to transfer data or receive updates. Second, we have a CNN-based wearable assistive system for visually impaired people walking outdoors by Ayusen Hesek. It provides greater mobility and independence, reduces the risk of accidents. The system requires regular maintenance. The system may not be effective in noisy outdoor environments. Third, we have a systematic review of urban navigation system for visually impaired people by Aman Taha. It can provide a comprehensive analysis of the existing research and development in this field. It gives a clear evidence base for the effectiveness of different navigation systems. Conducting a systematic review is a time consuming process that requires a significant investment of time and resources. Fourth, we have obstacle detection system for visually impaired person by Chipati Sharma, Sapna Bali, and Mr. Sunil Yadav. With a smart stick, visually impaired people can travel more independently without an assistant. It helps users to move more quickly and confidently without the fear of bumping into obstacles. Obstacle detection systems can be expensive to purchase and maintain. It can be complex to set up and use. Next, we have enhancing perception for the visually impaired with the deep learning techniques and low-cost wearable sensors by Biozoria. The system provides real-time feedback to the user. The low-cost wearable sensors are used, which reduces the cost of the system. The user will need to be trained to use the system effectively. The system may raise privacy concerns. Analysis of navigation assistance for blind and visually impaired people, a systematic review by Sulaiman Khan. It enhances the user experience and helps to identify the destination with navigation assistance. It provides better performance, reduces response times, or increasing accuracy. Analysis of navigation assistance can be a time consuming process requiring significant resources and expertise. The cost of conducting a thorough analysis is expensive. Moving on to next slide, we have methodology. A methodology for building a CNN-based object recognition and tracking system to assess visually impaired people can be divided into the following steps. The first step in building an object recognition and tracking system is to define the problem. The next step is to collect data for training and testing the CNN model. This may involve capturing images and videos of various objects in different lighting and environmental conditions. Once the data set is collected, it needs to be pre-processed to enhance its quality and remove any noise or unwanted features. The next step is to select a suitable CNN architecture for object recognition and tracking. Next, we have block diagram. The proposed system consists of a camera, headphones, and a Raspberry Pi digital signal processing board with a GSM and GPS module. DSP feeds object detection and recognition module, a live video input from the camera. The text to speech converter module reads the names of the things the model predicts will appear in the current video frame while wearing headphones. The labeled photo is additionally encoded by the Joint Photographic Expert Group encoder. The Raspberry Pi Foundation has developed a number of small onboard computers to handle limited control functions on the Raspberry Pi. A system on a chip with an integrated ACOM RISC processor and a powerful central processing unit is installed. The suggested solution makes use of Pi Anywhere 4G and LTE hat for the Raspberry Pi beta. The Raspberry Pi mini computer offers battery support, GPS, positioning data, and 4G mobile data. Next, we have flow algorithm. The flow diagram of CNN-based object recognition and tracking system to assess the visually impaired people is shown below. First, we have input, pre-processing, object detection, object tracking, object classification, audio feedback, user interaction, user feedback, system maintenance, and at last we have output. The system takes input from a camera mounted. The captured video frames are pre-processed to enhance the image quality and remove any noises. The pre-processed video frames are pre-trained to detect and identify objects in the scene, and once an object is detected, the system tracks its movement over time. The system classifies the detected object and provides an audio feedback to the user. The user can communicate with the system by voice instruction. The system provides feedback to the user about its action and status, and it updates periodically and object tracking algorithms to improve performance and accuracy. The system provides an output that informs the visually challenged people about the object which is present in front of them. Next, moving on to the results, the aim to develop CNN-based object recognition and tracking system to assist visually impaired people. These systems typically use cameras and image processing algorithm to detect and identify objects in the environment and then provide feedback to the user through audio or haptic feedback. A prototype is put to test with daily objects, the most typical item in everyday life, and the system is capable of quickly detecting and identifying them as shown in the figure. As shown in the figure here. The system accurately recognizes the table in the first frame and it informs the user. The bed, a person sitting on the bed, and a vase are among the various objects the system recognizes in the fourth frame. The user's current location is displayed to the observer when the option is enabled. The observer can view the user's whole trajectory as it is displayed on the Google Map. As it is displayed on the Google Map, the application will also gather the snapshots from the user periodically about the present environment and it is depicted in the figure here. The idea used in the selection of videos is that they should have potential disruptive phenomena, circumstances that are bright or dark for object detection, etc. It will also detect the items in the daily life in various settings like a human, a cat, horse, laptop, cup, bottle, etc. Some of the applications of CNN-based object recognition and tracking system to assess the visually impaired people are object detection, object tracking, text recognition, data collection, navigation. Next, we have conclusion. The CNN-based object recognition and tracking system to assess the visually impaired people gives a sense of surroundings and helps the visually impaired people visualize the area. The system can be customized to recognize and track the specific objects that are important to the user, such as their cane or guide dog, enabling them to locate these items more easily. A CNN-based object recognition and tracking system can be a valuable tool for visually impaired individuals, providing them with real-time information about the environment and helping them navigate safely and independently. By processing live video feeds from a wearable device and using deep learning algorithms to identify and track objects, the system can provide audio or haptic feedback to the user, alerting them to potential hazards and helping them avoid obstacles. Overall, this technology has the potential to greatly enhance the quality of life for visually impaired individuals, giving them greater independence and confidence as they navigate the world around them. These are some papers which I have referred for literature survey. Thank you.